Good morning. Migration rates of solutes. So solute nothing but the mobile base. Mobile base. The effectiveness of the chromatography. The effectiveness of the chromatography column is in separating two solutes depending in part upon the relative rates. Relative rates. So which the two species are eluted. Two species are eluted. Now these things can be known by distribution constant. Known by distribution constant or partition coefficient or partition ratio. Partition coefficient or partition ratio. So the migration rates can be, yeah, you have to calculate it. Okay, this is the distribution coefficient or partition coefficient is equal to S concentration of solute by concentration of the concentration in the stationary phase by concentration of the mobile phase. So the component present in the concentration of the stationary phase by concentration in the mobile phase. So this is the mainly here purpose is the effectiveness of the effective the effectiveness of the effectiveness of a chromatographic column chromatographic column effectiveness of the chromatographic column in separating two solutes in separating two solutes depends in depends in part upon the relative relative rates which which the two species are two species are eluted from chromatographic column. Now these things can be known by this can be known by distribution constant K or partition coefficient or ratio. That is the concentration of the S solutes present in the stationary phase, concentration of the solute present in the mobile phase. The ratio is called as a distribution coefficient. So this is mainly the depending on the distribution coefficient, the migration rate can be calculated. The migration rates can be calculated. So see here, this is a K is equal to the distribution coefficient. Here distribution coefficient nothing but whenever the stationary phase is solid, therefore we are using the which type of chromatography? Solid chromatography. Nothing but the here gas is a mobile phase or maybe liquid is a mobile phase. So gas liquid here gas solid chromatography or gas liquid chromatography we are using as a distribution coefficient. And if the mobile phase is either gas or here liquid, but stationary phase is liquid, in that situation, this is used as a partition coefficient. So partition coefficient or distribution coefficient K is equal to concentration of solute in stationary phase. Concentration C means concentration. Concentration of solute in stationary phase. Stationary phase means SP by concentration of solute in mobile phase MP. Yeah, stationary base, mobile base. Some terminology is there. What is a stationary base? Which is a mobile base? What is which is the analyte and solute and solvent? Yes. So this terminology is important. So mobile base. Mobile base simply denoted as a MP. Yes, mobile base. Mobile base nothing but the it is the analyte. Analyte means mixture, a component mixture and solvent mixture. Analyte means component mixture or and solvent mixture which travels through the stationary base. Which travels to the stationary base is called as a mobile base. It is the analyte. It is the analyte. Analyte means component mixtures. Component mixtures, component mixtures, and solvent mixture, and solvent mixture, which travels through, which travels through stationary phase, which travels through stationary phase, is called as a mobile phase. And stationary phase nothing but the it is the substance which is fixed in place of chromatographic procedure, which is fixed in the place of chromatographic procedure, and it is the phase to which solvent and analytes to which solvent and analyte travels through them is called as a stationary phase. Stationary phase is a fixed one in the chromatographic procedure, and a solvent and analyte mixture travels through them. So here stationary phase. So this can be SP. Stationary phase means yes, it is the substance. It is the substance. It is the substance which is fixed in which is fixed in chromatographic procedure. Chromatographic procedure, and it is the phase, and it is the phase to which solvent and to which solvent and analyte travels through them, travels through them is called as a stationary phase. So stationary phase is nothing but the fixed in the chromatography procedure. So and it is a this is phase here in which phase you are traveling through traveling here solvent and analyte. Solvent nothing but the mobile phase. Here fixed one is the stationary phase. So this is what is there. Analyte means what is the analyte? Here solvent is the mixture of the solvents. Are they so? Here analyte nothing but the analysis compound, nothing but the a fraction of compounds. So these two are traveling through the stationary phase. So stationary phase is the fixed in the chromatographic procedure. Next, here analyte. Here meaning aim of the analyte. Analyte means here it is a substance which has to be analysis, which has to be analysis in chromatographic procedure is called as a analyte. So analyte means analyte. Analyte means it is a substance. It is a substance. It is a substance which has to be analysis, which has to be analysis in chromatographic technique. Procedure. So this is called as an analyte. Analyte is a containing mixture of compounds. So it containing the mixture of compounds. Mixture of compounds. Mixture of compound. And analyte means it is analysis in the chromatographic procedure. Analysis in the chromatographic procedure. And you take a screenshot. So next one, LUN. LUN. And another one is a LU8. LU8. Here 8 ENT. ATE. So LUent means solvent mobile phase introduced in front of stationary phase. Yes, for example, you take this is a column. Yes, here column. So this is a cotton. So here which is there? Here this is a mainly is a bed. So bed is consisting silica gel. So this is a analyte. Analyte. So this is a analyte, and this is a only analyte. Here to bed silica gel is a cotton. So this is attached to the fixed to the stand. So this is a column. In this column, so LUent means solvent mobile phase introduced in front of the stationary phase. So this is the what happened here, stationary phase. Here bed is act as a stationary phase. We are introducing which is there. So here solvent mobile phase. Solvent mobile phase. Where is the yes head of the column? Are they introducing here front of the column? So therefore, this is introducing here. This is called as a LU end. This is a LU end. Next to what is the LU? LU. We are introducing solvent mobile phase to the column. The solvent mobile phase traveling through the stationary phase. And it can be coming to the here outside the yes from the column. The outside the here outcoming the solvent is called as a this outcoming solvent is consisting of the analyte also. So this outcoming is called as a LU8. Here LU8 is consisting of the only which is there. It consisting of the mobile phase plus analyte fraction. Analyte fraction. So what is the meaning fraction? Here analyte consisting the more number of the compounds. More number of the compounds. Here two or more number of components is present in the analyte. This whenever we are introducing the solvent mobile phase in the column in front of the column. So the solvent phase is traveling through the mobile phase, and here what happened? It can be LU8. LU8 is what happened? It can be taking the some of it during the solvent mobile phase travel through the station phase. Some of the LU8 analyte compounds also travel through the column, and these are the here traveling through this one, this is called as a this is a LUT8. This is consisting of the mobile base plus fraction of the analyte. Fraction of the analyte means your analyte minimum at least two compounds. Two compounds is causing. Whenever only one compound is there, not required for the column. Okay, so this is a LU8. LU8 nothing but the outgoing solvent. Here LU8 nothing but the yes, here introducing solvent mobile base. Here what is there? Here outcoming. Here introducing. So here LU8 solvent mobile base here introduces the in front of the column. So solvent mobile base solvent mobile base introduced in front of stationary base in front of stationary base. So therefore this is called as a LU end. So next one, LU8. LU8 means the solvent that leaves the column. Here from the leaves the column, the solvent. So here also which is there? Solvent. So solvent is introduced here, leaves from the here. So solvent that leaves from the column, with or without any separating components. So sometimes a analyte is there. Here analyte is coming, here may not be coming. So with or without any components is called as a LU8. It is termed as a column fraction. This is called as a column fraction or a mobile base with analyte fraction. So LU8 means the solvent that leaves the solvent that leaves the column with or without separate components is called LU8. LU8 is called LU8. It is termed as a column fraction. It is termed as column fraction. It is termed as a column fraction. So introducing your solvent mobile base, introducing it at the in front of the yes column is called as a LU and leaving from the column is called as a LU8. LU8 is mainly mobile base with the analyte fraction. Your fraction may be present or may not present. This is also LU8 is also termed as a column fraction. Next one, classification of the chromatography techniques. Classification of chromatography techniques. So chromatographic techniques are classification based on the mobile phase, stationary phase, and physical properties. So these are mainly classification here based on the physical properties and mobile phase and stationary phase. So here one is a classification into nature of the mobile phase. Second one is a based on the nature of the stationary phase, and another one is a based on the difference in physical properties of the stationary phase or difference in the interaction of the component with the stationary phase. So classification of chromatographic techniques based on mobile phase, stationary phase, and physical properties. Physical properties. Properties. First one is a classification is a one is a nature of the mobile phase. Nature of the mobile phase. Mobile phase mainly here two type is there. One is a liquid is a mobile phase, another one is a gas is a mobile phase. So it is a one kind of the classification. Second one is a nature of the stationary phase alone. Nature of stationary phase alone. So stationary phase mainly here two type of the stationary phase is there. One is a solid is the stationary phase, and another one is a liquid is a stationary phase. So gas stationary phase into that. So gas stationary phase is not there, and here solid stationary phase is the solid stationary phase, mobile phase is opposite. So only here mobile phase is a liquid or gas, and stationary phase is a solid or liquid. So this is a this is a second classification. Next third classification here based on the nature of the based on the nature of the physical properties. So based on nature of the physical properties, based on nature of based on nature of physical properties of physical properties of components in stationary phase, in stationary phase in stationary phase or difference in the difference in the interaction 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 of of components components with the stationary phase. So this is a one type of the classification of the chromatography techniques. Here mainly, classification mainly here depending on the one is the nature of mobile phase, another one is the nature of the stationary phase alone, and third one is the based on difference in the physical properties of components in the stationary phases. So physical properties is nothing but the here one polar compounds is there most strongly held in the stationary phase, and less polar compounds or non-polar compounds is there less interactions with the stationary phase. So difference in the interaction of the components with the stationary phase. This is another classification. Okay. Thank you to all. Take a screenshot.